Hello and good morning, everyone. Thank you very much for joining us today for Why Lighting Matters for ANPR Barrier Control. My name is Ellis McCoy. I'm a Security and Transport BDM here at Raytech, and we will get straight into our presentation for today. So let's just go through the agenda really quickly. We'll go through a quick introduction, a look at the common applications and some case studies that we've worked on over the past few years. Then we'll get into the real meat of the presentation, looking at the challenges, solutions, and how to actually specify lighting for ANPR type applications, or specifically for barrier control. Finally, we'll go through a quick little conclusion before a Q&A at the end. Just to do a little bit of housekeeping to start off with. So just to let you all know that this session will be recorded for future reference. Please keep your microphones muted throughout the presentation, albeit I believe they are as standard. So just please ensure that they're kept that way. What I would do is urge you, though, to use the chat box or the question box. I'm not sure how it interfaces on your side, but if you can ask any questions as we go through. So if you want me to expand on a certain topic or to clarify anything, pop it down as we go through, and then we'll go through everything with a proper Q&A session at the end. Further to that, so after the presentation, a feedback form will be provided. We really do encourage you to submit this form to our team at the end of the webinar. The feedback really helps. It kind of helps us measure learning effectiveness, gather insights for continuous improvement. And importantly, of course, it means that we can sort of develop these presentations so that they meet your expectations and in compliance with CPD standards. On that note, regarding CPD, so if you are collecting or require a certificate following the attendance to today's presentation, please email our marketing team. I believe the email address will be on at the end after the webinar, and then we'll be able to supply you with a certificate of attendance, and then you can obviously collect your points after that. So by the end of this webinar, participants, you'll be able to understand the fundamentals of ANPR systems and barrier control applications, identify common challenges affecting the plate capture accuracy, recognize the role of lighting, both infrared and white light, in improving ANPR performance, and hopefully have some practical solutions and specification hints and tips to help you better use lighting for reliable and efficient barrier control systems in the future. So let's get started. So just as a baseline, what's ANPR? ANPR, or LPR, which is often the term used in North America, very simply capture of or using technology to capture characters on a number plate, but for the context or the subtext of this presentation, we kind of expand this out to other OCR type applications, so optical character recognition. I know we've got people on the discussion today who are looking at container monitoring or other fast moving applications, for example, motorways, or even going as far as some rail stock type applications and serial numbering, that kind of thing. So while the context for this particular presentation is, of course, barrier control, we kind of expand that out. But focusing just on barrier control for the minute, what we've seen personally from our side is we've seen a real big shift from kind of like old manual systems with actual gates and such to fully automated setups. And ANPR really plays a crucial role in that. Allowing vehicles to be identified, access granted without stopping, and obviously for environments where there's going to be lots of traffic or people trying to get in and out efficiently and fast with as little friction as possible. These systems require good lighting in order to be completely reliable and get you good images of those number plates without missing any. So just to go through some common applications, we've seen obviously a big uptick in ticketless parking systems. Commercial and logistics sites, this is actually quite a hot one for us as we've been approached by some large e-retailers for their warehousing. Residential gated access, airports and transport hubs, border control and law enforcement, another big one for us at the moment, especially with conflict in Eastern Europe. The thing is, while all of these come under a single subtext of barrier control, the lighting requirements differ vastly, depending on the speed of the vehicle coming in, whether or not, of course, they have to come to a stop, ambient light levels, if it's particularly rural or if it's in a kind of away from city centres, is weather kind of a bigger issue, etc., etc. And of course, for each of these types of applications, it needs to be looked at individually when specifying both the camera side of things, but also, of course, the lighting. So just to go through a couple of case studies on where we've had our products used. The first one is Zurich Airport. So again, much like we previously mentioned, this is can be a very busy application. Lots of vehicles moving in and out, often in a rush, as we often are when we're going to the airport. So realistically, reliability for security as well as for ease of use is very, very important. In this particular environment, though, of course, it can be used throughout the day because obviously the airport's open until very late at night, especially this particular airport being quite a big one, and different weather conditions. Obviously, for this particular camera inside, not so much of an issue, but for the ones outside, you get all sorts of different weather from snow, rain, sunshine. And with regards to this particular camera, obviously low light with it being inside without very much general area lighting. In essence, the infrared in this case is absolutely a prerequisite in order to capture those plates reliably and allow for that system to work effectively. However, I kind of wanted to use this as a starting point because this is, dare I say, the easiest setup to achieve good results. You know, it's close to the entrance, narrow field of view, camera and lighting mounted very closely together. There are some things that they could have tweaked, so they could have maybe had the lighting closer to the vehicle, for example, so that it's going to bounce off the plate from a closer range, and therefore more light will reflect back into the camera. Of course, in order to do this, you need to have the camera and the lighting on the same axis, for example. So you can, for example, have the lighting on the actual barrier itself with the cameras mounted to where they are, because then the lighting wouldn't reflect back in the correct location. But even all of that to say that even for quite simple applications like this, there's certain things that you can think about and tweak to try and make a setup more efficient and effective in doing what it's supposed to do. The next one is a shopping center and mall in Japan that we worked with our parent company on, Optex. Now, this is kind of like the next step up because, as you can see, there isn't actually a physical barrier stopping vehicles from going in, and therefore you're going to have more variable speeds coming through. With that in mind, they decided to go for a mix between the i4 and the i8 lamps in order to achieve maximum impact and ensure that the system was working reliably. And this one starts to go into accounts where it's not just for security, it's also for commercial reasons, because in this particular example, they started to apply charges after 3 hours of vehicles being parked. And so they needed to reliably be able to capture vehicles coming in and out in order to make that return on investment. And that, of course, is a big aspect of these types of applications, return on investment. On that same note, so this is little car parks in the UK. And this was the same sort of example as the last one, where it is monitoring for vehicles and their parking times, albeit this is more of a fine rather than charging system. So if vehicles outstay their welcome, they're fined after being there for 2 or 3 hours, I believe. The tricky thing for this one, though, is that for Lidl's in particular, they wanted to install the cameras and the lighting on existing columns in the car park, and rather than installing a specific ANPR column in order to do that. Now, what this meant is that the camera and lighting was at quite extreme angles to the vehicles actually approaching or entering the car park. And we'll look at this a little bit later, but some of them were essentially outside of the 30-degree retro reflectivity zone of a European plate. it's widely considered that angles kind of outside of 25 to 35 degrees from the front of the plate will get less light reflected back. And so in this particular circumstance, they needed to ensure that they had a lot of light in order to counteract that extremeness in angle and still be able to capture plates reliably. Now let's dive into some of the challenges that you can see when doing ANPR type applications. So first and foremost, you've got headlight glare. So the major issue, of course, is that vehicles will be shining light, and depending on where your camera is actually positioned, they could be shining light directly into your camera, which can cause overexposure, bright spots. Um, this is also kind of like a big issue if you're just using inbuilt infrared, which potentially can be overpowered. But even if your camera isn't positioned directly in front of the car, you can also see reflection from wet surfaces. So if it's kind of rainy outside and car headlights are bouncing off the wet tarmac in the rain, that can also cause overexposure in certain areas or the loss of crucial details. And this ultimately comes down to you know providing enough power angle control in order to counteract that and make sure that you're able to achieve good images still. The next challenge is actually the plates themselves. License plates aren't standardized globally. So in the UK, we follow a very consistent standardization alongside most of the European bloc. However, even within Europe, we still have Belgium, for example, which uses red lettering on a white background. But if you look further afield from the UK, you've got the US with 50 states and a district. You've got Canada with 10 provinces and 3 territories, all with different plates of various different lettering colors, background colors, size, shape, styling, etc. Then you look over to the Middle East, and again, you have the same sort of deal with different materials, but also importantly, they're also the characters themselves, because you have some very intricate charactering, also some small lettering, for example, which you need to be able to accurately pick up in order to get all the information that's required for those installations. And this all comes down to a few different reasons. So firstly, the material. You've got different material plates, so from plastic or retroreflective materials, so it can be plastics or paints, but they could also be made of various different degrees of metal, painted metal, etc., which all has different types of reflection. Um, the size and quantity of the plate is also very important. Obviously, the size being the size of the lettering, etc., which makes it harder to pick up, but also the quantity, albeit that's very regional. So some places in America, for example, will only have a single plate fitted. So of course that means the installation itself needs to be always facing in a certain direction and not both. The color of the lettering affects the choice of lighting, mainly wavelength, of course. This is because red lettering can reflect light almost as well as the white background that it's usually situated on, which ends up providing very little contrast for analytics to pick up. So in order to counter that, often customers will use white light, which we've got a little case study to look at in a bit. And then, as mentioned, so some of the fonts can be very tricky to pick up. Most commonly seen in Middle East, where, as mentioned, there's a lot of intricate lettering that can make, uh, you know, dirt or the dust on the plates. It can make it very tricky to see. Of course, actually, converse to that, we actually have some states which assist ANPR systems in order to work. So, for example, we've got this example of a Dutch plate, and you'll notice on the R at the end of the plate there, they've cut out a little notch at the top, and that's so that even if there is some dirt or dust, as mentioned, partially covering the plate, that R has a better chance of being picked up versus a B or an 8, for example. So it's all very varied, and certainly specification installation design has to take all of that into account ahead of time. So going back to the reflectivity, this is kind of like a little bit of physics, but you've got generally you've got three different types of reflection when light hits an object. The most common is diffuse reflection. So that's when an object reflects light in all direction in varying degrees. This is actually in the natural world, this is the most common type of reflection. And the majority of objects reflect light in this way. So the problem with this, of course, is that if you are shining a light on this type of surface, or if a plate has this a diffuse reflection or reflective characteristic, then only a fraction of that light will actually be bouncing back into your camera lens. And so what you need to do is ensure that an increased amount of light is actually supplied, so that the amount of light that's being reflected back is enough in order to see. The least common type of reflection is specular reflection, and that's when lighting will bounce off a surface and effectively bounce off in the opposite direction. This is most commonly seen in bodies of water, for example. So when you're getting those lovely Instagram shots with mountains reflected in the lake, etc., that is specular reflection. I love teaching my kids all of this stuff. It's very interesting. And then the last one is retroreflectivity. Now this one is pretty much a man-made construct, as mentioned, either because of plastics that are used, certain types of like beading material, or certain types of paint spec. And the idea here is that it reflects all of the light back to the source of the light. And of course, this has to be taken into account when you're thinking about the camera placement. So if, for example, you're looking at um, European plates, which are commonly retroreflective, apart from Belgium as mentioned, then you want the camera to be very close to the lighting source in order to make sure that the lighting is all bouncing back into your camera. This all goes to say, though, that it's not just a lighting emphasis. You need to take into account the entire solution. So you need to have a suitable camera, you need to have a good lens, filters in some cases. So for example, if you're using like an infrared bandpass filter, so that you're only looking in black and white through day and night, or as we'll come on to later on in the presentation, if you're looking through things like car windscreens, you need to have a polarizing filter. And then of course the lighting is incredibly important. As our now chairman would say, garbage in, garbage out. If you don't have all of these bases covered, then you're simply not going to get a good outcome. To give you an example, to round this section off, partner in North America, Watchtower, and they started to notice readability issues at nighttime in the state of Tennessee. Now, what had happened is that Tennessee and Indiana changed all of their license plate design, specifically the color and the material. So they changed it to a blue lettering and plastic material, which had a lot lower levels of reflectivity, or rather, they were more providing more diffuse reflection. And Watchtower over this course noticed a big drop off in their readability, the percentage accuracy. So they called in our North American team, RSI, and they did a load of testing. They found that actually it's the quantity of lighting needed to be vastly increased, and they decided to go with our 50 watts Varia 2 infrared light. And as you can see, the performance kind of speaks for itself. So where, especially on the plates with white lettering on the blue black background, were essentially unreadable even to the human eye, and especially also so to a analytics system or the ANPR system, that readability is vastly changed with the increase in infrared output. And so they very simply had to keep the rest of their system the same. All the cameras were still performing very well. It was simply just a case that they needed a higher level of infrared lighting in order to achieve the readability that they were requiring. So solutions from us and from other providers, you generally have three different styles of product. So first of all, you have different wavelengths of products rather. White light is the lesser used one. So white light is obviously visible light. It's all around us. It gives you color images. We generally don't consider on a like-for-like basis that white light will give you as much distance as an infrared product does. However, in some circumstances, specifically when red lettering or red backgrounds and higher contrast is required, white light is the only method in order to achieve good results. And so white light can be used as and when in the regions that require it. More commonly, however, we see infrared being used. Now, the standard wavelength of infrared that we will often prescribe is 850 nanometers. That's kind of like the industry standard. So within integrated infrared cameras, for example, they're all roughly 850 nanometer infrared. However, we do have alternatives as well. The benefit of infrared 850 nanometers is it's kind of that sweet spot between giving you the best performance while also being semi-covert, i.e. you can see the faint red glow of the LEDs themselves, but for traffic, certainly if they're traveling at speed, they won't see the red glow very dramatically. It won't look like a stoplight, for example. The other wavelengths offered at 940 nanometers. Now, this is theoretically completely invisible to the human spectrum, falls outside of our visible spectrum completely. We also use a cut filter so that no additional wavelength or no wavelength below 940 nanometers is emitted from the lamp. The downside of using this wavelength of light is a significant drop off in terms of performance from your camera. That's not because of the lighting itself. The light is actually often just as powerful as their corresponding 850 nanometers variant. However, camera performance, much in the same way that the human spectrum doesn't perceive that wavelength of light very well, cameras often don't either. And so you'll often see about a 50% drop off in terms of usable distances. However, where this comes into play is, of course, applications where no red glow at all can be required or allowed. So, for example, we'll commonly see this in train line type applications where the red glow, even just a very faint one, could be construed as a warning signal. Now, some people get around that actually by using 850 or lower wavelength lighting, but using it in perpendicular to the track, for example. But that doesn't come under the scope of this particular presentation. The third and final, or third primary offering that we see is 730 nanometers. Now, much converse to the 940 nanometer offering, this is very much within the visible spectrum of the human eye. And if you are looking at a 730 nanometers lamp in darkness, you would notice very clearly that it's a big red light, and that's noticeable at a distance as well. Now, the benefit here, and I'll show you some images later on in this presentation, is that we see that it provides better vision through car window screens. So for applications that require that, 730 nanometers is a very useful tool in order to use. However, as mentioned, because it is such a big bright red light, it needs to be used intelligently. So again, whether that be used off axis in a fast moving type application, or if it's for a barrier type application, I think that is more conducive to using 730 nanometers, as vehicles will be coming to a stop anyway. We've recently been invited to work on a number of toll station barrier type applications where they need to see inside of vehicles, and 730 nanometers is deemed to be acceptable, as mentioned, because the cars will actually be coming to a stop. Now, interestingly, while they're kind of like the three main options, we have been doing a little bit of testing with others as well, which yeah, I think we're at the point where we're kind of like happy to start talking about it. One of which is 810 nanometers. Now, the reason for going with that kind of like in-betweeny wavelength is we perceive that it's not as visible as 730 nanometers, so potentially better for use on motorway type applications, but it still gives you some of the performance for seeing through windscreens that 730 nanometers is able to provide. And so we're doing a little bit of testing at the moment with these types of wavelengths to see what we can get out of them and see where the sweet spot is with regards to the performance versus functionality versus how visible the light output is. The final kind of product subgroup is a hybrid product. Now, realistically, we use this less for ANPR type applications, but certainly the prospect is there, especially if we start to mix and match different wavelengths. But the idea here is that you can have two different wavelengths of infrared or white light or green light, for example, within a single product, which could be triggered on and off either via your network or via a hardwire input. So that is an option that is available, but yeah, certainly for more niche applications. As mentioned, this is just a little case study for white light. Specifically, this was for a project in Belgium where they're looking at containers filled with cacao coming into a food processing plant. Now, this is quite an interesting one. So our integrator in this case, Acadia, they needed to be able to create a system that would log and track trucks from different sites so that the containers were all appropriately food safe, and so it was kind of like it wasn't simply just a case of tracking vehicles coming into the area. It was also seeing where else they had been, how long they had been between trips, all this kind of stuff, so that all compliant with food safety protocol. But as mentioned, because the plates are predominantly going to be Belgian plates with the red lettering on the white background, white light is an absolute requirement. And in this case, they actually decided to also go with the pulsed white light products in order to get the best possible power output and clarity for that particular application. So the next thing, once you've decided on the type of wavelength of products that you're using, you can then start to think about the actual the whether or not you want a pulse product or a constant output product. Now, historically, and for still a number of applications, we will use constant output products. Quite often is the case that they will emit a sufficient level of power in order to achieve the desired requirements. And certainly for barrier control type applications, often is the case, vehicles might be stopped, so you aren't necessarily using as fast of a shutter speed, but also the distances are usually quite low. And so again, you don't necessarily need a powerful pulse product. But as mentioned, even for that last case study there, they thought that the increased power output from a pulse product was desirable in order to achieve that high level of power. So what does that actually look like in real terms? So for constant output, you have a product that's on 100% of the time. Lighting's always available to the camera, no trigger necessary, and obviously it's easy to set up. Essentially, if you're having it operate via photocell, it can be nigh on plug and play. Now the thing is though is that while the light is on constantly, and this is kind of like what you would essentially see, so intensity stays the same, light is on constantly, but your camera isn't capturing constantly, so there is a degree of wasted light even though it's capturing every frame and giving exactly the amount of light that might be required for a given application. And so then you might start to think about using a pulse product. So a pulse product is only on when the camera shutter is open. The important thing here, though, is that the pulse products require a specific input trigger, specifically a TTL input or output from the camera, rather. And so if you're looking at a pulse product as a potential solution, you need to make sure that the compatibility is possible between the camera and the lighting. Now, historically, that always used to be more machine vision type cameras. So you'd see the likes of Basler or IDS, or there's a number of different brands that require or that supply machine vision specific products that have this transistor to transistor logic TTL output. However, we've seen an increase in more security type camera manufacturers coming out with this offering. So I know, for example, Axis are bringing out a camera with a TTL output and a global shutter, which is compatible with our pulsed lighting. I believe Panasonic also have a camera with a TTL output as well that's capable of working with our pulse products. So there is a greater degree of compatible cameras that are available on the market, and specifically cameras that are kind of within the security and general traffic sort of sphere that would be compliant with the pulse product. Now, the thing is, while pulse products will give you a higher degree of power output, and we'll have a look at that in a second, setup and commissioning is more complex. So realistically, you want to make sure that the additional power output is actually going to be worthwhile the work in order to make sure that the system is working appropriately. Now, what that looks like, if you imagine that red line, the straight line there is the constant light output. That's what we would normally see from a 100-watt illuminator, let's say. Now, from a product, or rather 50 watts, actually, that's a best corresponding product for this example. So if you imagine that's a 50-watt output lamp, we can essentially offer up to 5 times more power with the corresponding product. So for a product that is both the same size and actually will give you or require less power consumption, you can get upwards of 230 watts of infrared output. So same product size, less output, less consumption, but almost 5 times the power. And that is the key benefit. And so while, and this is actually quite an interesting thing, because some customers will look at these products side by side and consider them to be the same, or I even got asked a few weeks ago how it really works, because they thought that the pulse products were simply just the same product turning off and on just through the camera shutter speed. But actually, if you broke those open, they're entirely different products, and there's electronics in there that allow us to drive the power considerably higher, but obviously using the same sort of like heatsink real estate, etc. Because it's only on for such a brief amount of time, you're not going to overheat the LEDs, and you're going to keep the overall lifespan of the product exactly the same. Now, when you're setting up a pulse product, it's important to go through the settings and making sure that it's all matching with your camera. So the camera will trigger the pulse product to emit a pulse. You can then differentiate how the pulse width, so how long you want that pulse to be. Usually then you can change the intensity, or rather the height of that pulse. Now that's typically kind of like a corresponding value with the actual pulse width. Obviously there's a certain multiplier that you're allowed to achieve without damaging the product or overdriving the product. Pulse frequency, so what's the frame rate? You need to match that. And then the timing and synchronization, so that might be the delay. So when the camera sends that output, how long of a delay is required for the pulse to actually match the camera shutter opening and closing. So just to give you a typical kind of scenario, pulse width 1 to 2 milliseconds, frequency 50 to 60 times per second, pulse intensity height up to 5 times the power. The light is actually only on 5 to 10% of the time, which in effect is giving you a significant energy saving. It's allowing you to give that a higher degree of power and the additional functionality that goes in with that. And that is why pulse products can be extremely powerful in the right circumstance. Obviously, given that the application demands that increase in power, it can be very useful. But each individual application needs to be individually tailored for. That's an important aspect. So we've decided what wavelength of light that we're going to use. Obviously in that as well, we need to think about the actual angle of illumination and matching that to your camera, which we didn't mention, but is also incredibly important. You've decided on whether to go for a constant output versus pulse product. Perhaps actually a really important part as well is how much power is required. And so this is kind of like an initial guide that we would suggest. So we often will go in looking at about 10 to 20 microwatts per centimeter squared, and we've actually just even this last week, we've been working on a customer to those standards. Now, to put this into perspective, for a normal video surveillance system, for like a security application, we would normally target a level of irradiance of 0.35 microwatts per square centimeter. So it's a considerable drop off or uplift in terms of the amount of light that we would recommend for these types of applications. Um, how do we know this? Lots of practice, lots of testing, lots of experience, and there is a degree of theory that goes into that. So if we use that 0.35 microwatts per square centimeter for video surveillance, we can then start to work up depending on the shutter speed of your camera, for example. So if we go from 1/50th to 1,000th, so 1 millisecond shutter speed, you're receiving 1/20th of the light. If we then look at f-stop, so if you're looking to cover a stretch of road, for example, and you need to zoom in, you're changing the f-stop value, then you might look at a further 1/16th of the amount of light. Filter losses, so every time you put a filter over your camera or the lighting, you reduce the amount of light that's going to travel through. And so you're looking at another 9/10 of the light. If you add this all up together, you're actually needing 355 times more light to match the stated distance versus our security data sheet. So if you look at our data sheets, that's how much more light you need versus what will be on there. However, it's not all working to get against us. If you're looking at a European plate, for example, you're actually going to get a lot more light back versus if you're looking at a person in a matte coat, for example, with which might offer a more diffuse reflection characteristic. If you are working with retroreflective plates, you're going to get more light back. So we can add a multiplier in there of 9 times more reflective versus a diffuse reflection. All of that to say that you need 40 times more light in order to match the stated performance of our security products, which gives us about 14 microwatts. And what that means in terms of actually calculating is that you could effectively divide our datasheet distances by 1/6 to give you a usable distance for an ANPR application. Now, I think this is a little bit pessimistic, and so the next important aspect is testing. What we've found is that while that theory adds up and is certainly very true on paper, the reality is that not all applications actually need that level of light in order to achieve a good image. Some do, some don't. And what we would always recommend and what we try and support customers to do is to carry out testing. Testing, super important to actually find the real world performance of the camera lighting filter to determine how much light is required. This has actually come up very recently. So for example, 2 long range applications that we've worked on. This particular one alongside a Hammer camera. Hopefully I can get the video working for you. Yeah, there we go. So we'll skip forward a little bit. So for this particular application, we were looking 200 meters, and this is for a barrier entry application, 200 meters, and cars won't be traveling at 70 miles per hour, but for the case of the testing, we thought we might as well actually do that. Now, this was a proof of concept for an application whereby, much like that little example earlier on, they didn't want to install additional columns for the ANPR for the barrier entry into a large car parking area. they wanted to be able to mount their solution on the building itself. And so they wanted to check whether or not we were actually capable of capturing plates reliably at this 200 meters mark. So this was in collaboration with Vaxtor Vaxtor ANPR system, Hanwha's camera, and then the Raytech Vario 2 i16-1. Now, when we looked at this on paper, we actually brought 4 i16s. We thought that we would need a considerably bigger amount of light. However, in reality, because of the light sensitivity of the camera and the sole use case in that we were just trying to find the number plates and nothing else, we're actually able to reduce that down to a single i16 in order to achieve the desired results, which is just under half of the stated max distance of that product. And so this really goes to emphasize the importance of testing. So while we can do you calculations based on the math, the real world application of that math isn't always as it would seem on paper. And so we do really try to nudge customers to at least do an initial proof of concept to provide that kind of like proof of concept. Other considerations. First of all, IP technology. While a lot of our products are plug and play, as mentioned, you would wire them up and they will operate via photocell turning on at nighttime or simply on 24/7. We do also have the ability to use our IPPoE lamps as well, which can be triggered and manipulated over the network. Our previous case study that we looked at for Tennessee and Indiana, for example, they decided to go with the IPPoE products on the basis that they can log into them externally, they can play around with the power settings, and they can also check on the operational status of the lamps. They can do troubleshooting all from the comfort of their office. And so that is an important aspect to consider as well, whether that would be useful for your particular application. That might also be kind of best utilized as well when you consider that we're seeing an uptick in kind of like AI, obviously in apostrophes, and machine learning in ANPR as well. Perhaps having the ability to smartly trigger lighting or change lighting output depending on the scenario that a camera is looking at, or the weather conditions, or the distances of vehicles, etc. That could all come into play and be very useful for a given application if that's a requirement or a desired input. The style of product as well. So as mentioned before, we for projects we've done other wavelengths too. So for example, for a project in the Middle East, we supplied our IP products, but in a red-green setup that they could use linked into their existing security VMS software by the IP integrations that we offer. But they wanted it specifically for the barrier control to advise cars if they're accepted to come in or not. We've actually done this in a hybrid setup as well, so a single panel illuminator with half red lighting and half green lighting. Again, that was a proof of concept that I believe we did with AWS, which was went down quite well. So there's all sorts of different, different styles of products or more bespoke solutions that can be offered should the situation or application demand it. Something we're also seeing a lot of is cloud-based ANPR solutions, or just cloud-based surveillance solutions in general. Now, one of the key things here is that customers are usually charged on the amount of storage that they desire and also the bandwidth that's required. The interesting thing here is an aspect of having additional lighting is that it actually reduces the strain on storage and bandwidth. And this is kind of quite a tricky one for us to sell on, because it's hard to give you a specific number that it applies to, unlike the shutter speeds multipliers that we discussed earlier. We can't give you a percentage increase or decrease in effectiveness. But simply by having an image that has better clarity, you've got less noise. Usually then the compression algorithms on the cameras can work more effectively. It'll reduce the amount of data that needs to be transmitted from any given stream. And so we can sort of like around and affect a cloud-based solution and make it more efficient by having better lighting. And that's a kind of a key consideration as well if you're using a project like that or working on a project like that. Lastly, as mentioned, seeing through windscreens. Now, we've been attending Intertraffic for a number of years now, and when we first started going, it was very simply we need to capture number plates. Then over time, it became an issue of we need number plates and we need to be able to capture the make, model of the vehicle as well, color of the vehicle in some cases. Last couple of attendances, we've seen a massive uptick in the desire to be able to see inside of vehicles. And this can be done for a number of reasons. It could be, for example, high occupancy toll roads in the US. We've seen a big one for where they need to be able to see how many people are actually inside of the vehicle and whether or not they're able or allowed to be driving in a high occupancy road. Also toll stations to be able to identify, recognize individuals as they're crossing state borders. We've been, as mentioned, working on a project in Australia where the user in that case wants to be able to, I believe, find or identify potential suspects, that kind of a thing. There's also big projects in the Middle East where that's a desire as well. Also things like people using mobile phone usage or lack of awareness when driving, that kind of a thing can all be tracked by seeing through windscreens. Now, usually seeing through windscreens is very, very difficult. You're looking at as mentioned previously, you're looking through a pane of glass, which reduces the amount of light that bounces both ways, so both the light going into the vehicle but also outwards. Further to that, windscreens are literally designed in order to stop a degree of infrared lighting going through, with the original intent that it would stop the cabs from actually heating up through sunlight going through it, for example. But all of this, of course, means that it's more tricky for us to get a good shot due to that reduction. This is actually kind of like this difficulty is increased when you start to look at side windows, tinted glass, or in some states that allowed tinted front windscreens, for example. That can all have a big impact on the amount of light that's able to transmit through that windscreen and bounce back it to your camera. All of this to say is that through our testing, this is kind of like some examples of shots that you can see whereby the 730 nanometers is a massive or provides a massive increase in performance for this type of application. But as previously mentioned, the important thing here is that 730 nanometers is that big bright red light, so it can only be used for certain applications whereby that won't be an issue, i.e. for a motorway type project where a big red light could be a stop signal or warning signal, for example, to drivers driving along. So in summary, ANPR obviously provides seamless, secure vehicle access using number plate recognition, which you need reliable lighting in order to achieve. Commonly used for vehicle entry, parking systems, border control, industrial sites, logistics hubs, etc. You've got a lot of challenges, which include things like vehicle headlights, the actual number plates themselves being tricky to pick up, whether that be due to the material or the lettering, for example, weather, the speed of the vehicle, etc. We've looked at the offering from Raytec in terms of the infrared lighting, or sorry, the wavelengths of light that are available, but also importantly, whether or not you want to consider a constant versus pulsed lighting product to satisfy your requirements. And then we've looked at some other considerations, either due to the style of product that you might want, but also different applications such as the analytics that are increasingly being used, or cloud systems. Finally, and just to re-emphasize, testing is incredibly important. We would always recommend, and obviously this has to be somewhat brand agnostic, but this is something that we support a lot here at Raytech, providing a series of demonstration products for proof of concept, and we would always recommend customers do that where suitable. So with that, we will go to some questions. I'll just have a quick look. So IP red and green lighting, reaching out for this. Yes, absolutely. We've actually got a few demonstration products in-house ready to go. So if you want to try this out, then please let us know. Michael Fluck has asked, what's the max pulse width? Enough for a rolling shutter camera, 3 to 4 milliseconds. So the max pulse width is essentially a lamp that's constantly on, right? And we can do anywhere in between. The longer your pulse width, the change in multiplier of the amount of power that we can output. The problem is that for a rolling shutter, we can't synchronize the pulse with the camera shutter. So what this leads to is either a reduced clarity, so literally less performance in terms of your camera, or just missed frames altogether, which is not what we want. So for rolling shutter cameras, we would usually go with a constant output product. We wouldn't use a pulse product for that type of application. And this comes down to the camera compatibility is really, really important when you're looking at these types of applications. Lev has asked if 810 nanometers is already available for testing. I'm going to get a kicking from our technical department, but we do have a couple of samples at the moment. They are in high demand, so we have them going out to customers already. So yes, let me know, and we can add you onto the list of customers looking to test that out. Tarura asked if the IP products can support HTTP commands. Yes, absolutely. So this is actually kind of what we consider our get out of jail free card. So we have a degree, a range of IPPoE or like software integration packages, which you can download for free off of our website. But we have a full HTTP API, and we actually have a really nice command creator. So it's clicky box exercise of getting the desired outcome from the lamp. You can then copy and paste that directly into your output on the camera or the software that you're using, and then that should all work absolutely fine. Kai has asked if the slides will be shared. Yes, the slides, this has all been recorded, so the slides and the recording will be shared after the fact. I think you'll get an automated message following the webinar with all of that available. Emma has asked, are asymmetric beam lenses available for your traffic lights? Some. So for the, if by traffic lights you're regarding our pulse products as the traffic lights, we have different ranges. So the PSTR Pulsar range, they can use all of the same lensing as our Vario 2 constant output products. And we have a really wide range of lensing for that, both asymmetric and circular. Get in touch with us to see what beam angle you require. Hopefully we have something that matches, but actually what we'll often do as well is we'll put something together specifically for custom applications. We've done all sorts, whether it be kind of like weird and wonderful angles or swapped angles, because obviously usually we would be looking in landscape, but if customers are using portrait, then we can swap the angles around, all that kind of stuff. So the answer to that is yes on one of our ranges. And yeah, get in touch and we can assist. Let's have a look. Yeah, sorry, I realized on one of the screens I didn't click onwards, so I've got a few messages saying that the screen was stuck. Hopefully that despite that you're able to get all the information that I was kind of trying to translate, and apologies for that. That was my user error. Michael Fluck has asked if the light needs to be in the same axis as the camera. To a degree, it depends on the type of plates that you're looking at, and I'm conscious of time here, but if you're looking at retroreflective plates, we have to keep in mind that all the light will be reflected back to the source of the lighting itself. And so if you're looking at retro plates, you want the camera and the lighting to be on the same axis so that lighting is bounced back directly into your camera. That's actually less important if you're looking at other plates. So, if, for example, we've been working on an application or big applications in Middle East across Saudi and UAE, where they found that that's not actually a necessity, and that's primarily because the plates are actually transmitting diffuse reflection, and so they get just as good performance if the camera and the lighting is slightly separated versus having it on the same axis. So in answer to that question, yes, if you're looking at European or British plates or other nations with retro plates, not necessarily the case if you're looking at plates with a more diffuse reflection characteristic. Perfect. I think that's everything for now. Thank you all for joining. Sorry about the technical issues that we had. And but I appreciate everybody sticking on the call with us. Hopefully it was informative, and yeah, as mentioned, these slides will all be getting sent out to you shortly afterwards. So thank you again for all of your time. Really appreciate it, and yeah, look forward to speaking to you in the future. Thanks very much.